Okay, welcome back to WSHS Algebra 1 Virtual Tutor. What we're doing today is dividing polynomials by binomials. So when we're dividing polynomials by a binomial, the first thing we want to make sure is that we actually have a binomial that we're dividing by. Okay, so this objective says factor completely the quotient, which means division, right, of polynomials using a binomial divisor. So how many terms does a binomial have? A binomial should have two terms in it. So you want to make sure that when you're doing these problems, you identify that you do have a binomial in the divisor. Okay, so example 1, division by a binomial. What I like to do is set them up vertically. So I like to use a fraction bar. You don't have to if you don't want to, but I like to see them that way. So I'm going to rewrite this as 10x squared minus 3x minus 4 divided by 2x plus 1. So I do have a binomial in the divisor, so I'm good to go there. So what I'm going to do with these is the reason why we're dividing them this way and why we can say we can divide it this way is because technically this 2x plus 1 here is one of the factors of 10x squared minus 3x minus 4. So by dividing this whole polynomial by one of its factors, we can actually find the other factor. So we're doing the division to find the other factor. That's what's really going on here. So what I can do is I can take 10x squared and I can actually divide it by 2x. And then I can take the negative 4 and I can divide it by the positive 1. I don't necessarily need that middle term. I'm going to show you where that middle term comes from in a minute, but let's go ahead and do this math first. So if I'm going to separate these, I would then divide them separately. Okay, so 10x squared divided by 2x. Well, 10 divided by 2 is 5, and x squared divided by x is simply 1x left over, right? So we know this from our rules for dividing with exponents. And then the other part we have is the negative 4 divided by positive 1. Well, negative 4 divided by positive 1 is a negative 4. So I can say that my answer is 5x minus 4, which is actually the other factor. So this is my answer, but this is also my other factor. So what do I mean by other factor? And where does that middle number come from? So if we're doing the division, we can always check our answer in math by going back to the original problem or doing the opposite to get back to the beginning. All right, so if we were dividing 10x squared minus 3x minus 4 divided by 2x plus 1, we said our answer was 5x minus 4. Then we can actually check by taking the 5x minus 4, and then the opposite of division is multiplication, right? So we can multiply the 2x plus 1 times the 5x minus 4 if we wanted to check, because the opposite of division is multiplication. So here I now have a binomial times binomial situation here. Binomial times binomial. So we said when we have a binomial times binomial, we like to box it. Okay, so I can use the box method there to check my answer. So I just need one to be written on the top as my length and the other one on the side as my width. So I can say that this is 2x plus 1 times 5x minus 4 if I want to go ahead and check. So 5x times 2x is 10x. Then I have 5x times 1, which is 5x. I have 2x times negative 4. That's going to give me a negative 8x. And then negative 4 times 1 is a negative 4. So remember, again, when we're multiplying binomial times binomial, a lot of the times, not 100% of the time, but most of the time, we can safely say that the diagonals here should be like terms, but you always want to verify that. So if they are like terms, we can go ahead and add those two. So our answer would be 10x squared, and then we have a negative 8 and a positive 5. That gives me a negative 3x minus 4. So I know I did this correctly because if I check this was my original problem, my polynomial, my numerator, right? And if you notice, that's where that negative 3x comes from, right there. Okay, so that came from combining our like terms when we multiplied back to check our answer. So if you were wondering why not the middle, because the middle kind of takes care of itself when you check back and multiply. All right, so when we are dividing, all we need to really do is divide the first term in the numerator with the first term in the denominator, and then the last term in the numerator with the last term in the denominator. You don't have to check your answers. It's not a requirement, but it is highly recommended that you go back and check your answer to make sure. Okay, so example 2. We have 9n squared minus 15n minus 1, and we're going to be dividing that by negative 7 plus 3n. And I know it's division because I see this fraction bar, and anytime you see a fraction bar, this does mean divide. So we said earlier that we're going to take our first term divided by the first term and the last term divided by the last term. We don't need the middle. Okay, now there's a problem here though. If you see here, can you do 9n squared divided by negative 7 and get a whole number that's nice and pretty for us to work out with in math? And you can't. Same thing on the other side. Can you do negative 1 divided by a positive 3n and get a nice whole number that looks good as a factor here for us? And you can't do that as well. We're going to wind up with decimals here. The problem with this one is that it's not written very nicely for us. It's kind of funky there, right? So what I can do is I can actually take this denominator here, and because of the commutative property, right? Commutative property says that we could change the order of what's going on here, commutative property of addition, and we can rewrite it without having to necessarily change the answer. So based on the commutative property, I can go ahead and rewrite this bottom, this denominator here. So I'm going to rewrite it. So I'm going to leave my numerator the way it was, 9n squared minus 15n minus 1. And now I'm going to rewrite the denominator here. Instead of the negative 7 being first, I'm going to write the 3n first. And then instead of the 3n being last, I'm going to put that negative 7 there. Now you want to be careful and make sure you're following the pattern here, right? So, and the signs, you want to keep your signs the way they are. So this negative 7 up here, I'll get a letter for you. So this negative 7 has to match up here. You have to make sure you're taking that same sign there, okay? And then this 3n was positive, and have the 3n positive here. So when you rewrite it, you want to make sure you're following and you're keeping those signs there where they are. Now this is a lot prettier, it looks nicer. I can set it up better. I can divide much easier this way, right? Because I can take the first term and the first term and divide them, and then I can take the last term divided by the last term. So remember, for these, and only if we have them set up like this, only if you have a binomial in the denominator, can you do this? Can you set it up this way? Okay, trinomial on the top, binomial on the bottom. Trinomial in the numerator, binomial in the denominator. All right, so let's go ahead and divide this. We have 9n squared divided by 3n. So 9 divided by 3 is 3. And n squared divided by n, if I've got 2 n's up in the numerator, 1 n in the denominator, 2 minus 1 is 1. So I have 1 n left over. And then for my last terms here that I'm dividing, the negative 1 divided by negative 7. Well, negative 1 divided by negative 7 should be a positive 1/7. Okay, so this one didn't work out the way it should have. There might have been a typo on this one. If we wanted to change this, I might change this problem just to give you a better example, make it look a lot nicer. If, let's say, this was a minus 14, that might work out better. Because in Algebra 1, they shouldn't get that difficult for you in Algebra 1. Later on in Algebra 2, you'll start to see a different way to divide like this. All right, so let's say I'm just going to change that just to make this a lot of a much neater problem to deal with here. So if I had negative 14 divided by negative 7, then we would make that a positive 2, right? Because we can say that negative 14 divided by negative 7 is positive 2. So that would be my answer there. All right, example 3. So here's a word problem, and you might come across a couple of these. It says here the area of a rectangular garden is 3x squared plus 6x minus 27. If the length is 3x minus 3, what is the width? So we've got a lot of information going on here. First thing they told us was the area of a rectangle. So we should know that the area of a rectangle is equal to length times width. That's how we usually find it, right? So they gave us the area as 3x squared plus 6x minus 27. And then they told us that the length was 3x minus 3. So we are looking for the width, right? So how would I find the width? Well, if I'm trying to solve for w, if I'm trying to get w alone, so this goes back to the objective 6 with literal equations. When you're trying to solve for one of the variables, you have to undo what's going on, right? So it's kind of like solving an equation, but with more than one variable. So if I wanted to solve for the width and get the width alone, then I'm going to have to divide by the length, right? In order to get width alone. So if I'm looking for width, that's the same as taking the area divided by the length. And vice versa. If I'm looking for the length, then I would take the area divided by the width. So that's how I'm going to set this problem up. If I'm looking for the width, I would take the area, 3x squared plus 6x minus 27, and I'm going to divide it by the length of 3x minus 3. So now we have a problem that we've been doing, right? So we have our trinomial divided by our binomial. We said we don't need to worry about the middle. We can take the first term divided by the first term and the last term divided by the last term here. So 3x squared divided by 3x would be 1x, right? So what would happen here, 3x squared divided by 3x, the 3's cancel out, so I'd be left with 1x left over, right? The 2 x's on the top, 1x on the bottom, those cancel, there's only 1x left. On the other side, we have negative 27 divided by negative 3, which would be a positive 9. So our answer for the width would be x plus 9. And then you can go back and check your answer, do the box method, and you should end up with 3x squared plus 6x minus 27. So that'll show you that you did get it right. Okay, we're going to do just a couple more practice problems to make sure you're comfortable with this. So the first one says divide. So I'm going to go ahead and write 32r squared 20r minus 18 divided by 8r plus 9. We want to make sure it's set up right so that we can divide nicely here. Okay, always make sure you're taking the sign in front. So like this negative 18 here, make sure it's a negative 18 and not positive 18, okay, because that can throw your answer off as well. All right, so 32r squared divided by 8r. That's going to give me 4r. And then we have negative 18 divided by a positive 9, going to give me a negative 2. So my answer for this one would be 4r minus 2. Okay, number 2, we have 10n squared plus 64n minus 42 divided by n minus 6. So again, it's set up nicely for me. I don't have to rearrange anything here. I do want to be careful with my signs. I'm bringing those signs to the front, or bringing those signs in front with my expressions here. All right, so we have 10n squared divided by 10n. And what's going to happen here are the 10s are going to cancel. So we have 2 n's on the top in my numerator, 1 n in my denominator, so I only have 1 n left over. And then on the other side here, we have a negative 42 divided by a negative 6. Negative divided by negative is a positive. So my answer is n plus 7. Okay, a couple more area problems here. So the area of a rectangle measures 9v squared minus 66v minus 48. And if the length is 9v plus 6, what is the width? Okay, so we're looking for width again. So remember we said area is length times width. So if we're looking for width, then that means we have to take the area divided by L, right? So area divided by L equals width. So we can take my area here, 9v squared minus 66v minus 48, and I can divide it by 9v plus 6, and that will give me my width. So 9v squared divided by 9v, well 9 divided by 9 is 1, right, or those would cancel out, and then we have v squared divided by v, so there's 2 v's on the top, 1 v on the bottom, there's only 1 v left over. For the other side here, or last terms, we have a negative 48 divided by a positive 6. So negative divided by positive is going to be negative here. So this is v minus 8 as my answer. Okay, last one, another area, length and width problem here. So we're going to have to divide here. It says the area of a rectangle measures negative 57p plus 56 plus 7p squared. If the width is 7p minus 8, what is the length? So this time they reversed the length and width here. But we're going to solve it the same way because area is length times width. So if we're looking for the length this time, I have to take the area and divide it by the width in order to get the length. So area divided by width equals length. So let's take our area, negative 57p plus 56 plus 7p squared. And we're going to divide it by 7p minus 8. So when I see this here, I notice that I can work this one out because I have negative 57 divided by 7 here. Not to the 7p squared divided by 8 plus, guys, like that. Let's see here. 7p. I'm going to fix this one for you. 57 divided by 7. Let's make this 56 here. Oh, I know what the problem is. I'm sorry. I'm sorry about that. Let me fix this again. It'll work out just fine. What we got to do is just rearrange this here. So I'm going to rewrite that. Negative 57p plus 56 plus 7p squared divided by 7p. All right. So this this numerator here, this numerator is not written in the order that we usually like to see it. Okay, standard form of a quadratic, we talked about this before, standard form of a quadratic is written when you have, typically looks like this, where you have the ax squared plus bx plus c. All right, so we have the quadratic term, the x squared term written first, the linear term, or the one with a single variable in the middle, and then the constant, which is the one with no variable at the end. So I notice that this is not written like standard form. So I can rearrange, again, commutative property says that we can rearrange this to make it look like standard form. So I want to rearrange this and rewrite this with my quadratic, my squared term written first. So my squared term is 7p squared. And it's a positive, right? So I want to make sure I keep it positive. My middle term here, the linear term, is the one with just a single variable. So the linear term is actually negative 57p, because that has just a single variable p. And then my constant is the number without any variables attached to it. So that's going to be 56 here. Okay, so now I've rewritten that numerator. Now I can easily divide it by this denominator here, 7p minus 8. So this will work out perfectly for me. So sometimes when it looks like you can't really divide very well, you might want to double check and make sure that it's written in standard form or it's written in proper order so that you can divide it. All right, so this is much nicer for us here. Okay, so we have 7p squared divided by 7p, and then positive 56 divided by negative 8. So 7p squared divided by 7p. 7 divided by 7 is 1. And then p squared divided by p, there's just going to be 1p left over, right? Because the 7's cancel out. And then 56 divided by negative 8. Positive divided by negative is a negative. And 56 divided by 8 is 7. So my answer is p minus 7. And that is it for dividing polynomials, or most importantly, trinomials, by binomials.